Welcome to week number 10 of the live interactive sessions for sustainable transportation systems. I am Seydev Naidu, a PhD scholar from the Civil Engineering Department at IIT Madras. Okay, so let's start with an overview of the concepts that were covered in week 10. Okay, so the first lecture of week number 10 was focusing on decarbonizing the transport sector. So what is this decarbonization? So basically it means that to reduce or eliminate the CO2 emissions from human activities, right? So this is what we call it as decarbonization, right? So why are we interested in this? Because carbon dioxide is one of the primary greenhouse gases, right? And greenhouse gases contribute to climate change, right? So this is a very critical issue, right? To decarbonize the transport sector, especially because transport sector, as we have seen before, is one of the significant contributors to this, greenhouse gas emissions, right? So that's why we have a strong need for decarbonizing the transport sector, right? So that was the focus of the first lecture of this week. So we looked at different measures for achieving this decarbonization, right? So how do we go about achieving this decarbonization? So we have different ways. So one, we can reduce our energy needs, right? So by lesser travel, right? So we can reduce the energy needs and also the resulting greenhouse gas emissions, right? So we can go for cleaner fuel alternatives, right? So from mostly we are dependent on fossil fuel for our transportation needs, so which creates a lot of emissions, right? So we could go for other non-fossil fuel based alternatives, right? So which are much more environmentally friendly, right? And we can also go for a better efficiency, right? So we know these emissions are because of improper conversion or incomplete combustion of the fossil fuels, right? So if you go for better efficient conversion methods, right? So we may be able to reduce the amount of carbon dioxide that is being released, right? So these are some of the measures that we were discussing in the first lecture, and also policy, different policy framework that can also help in the decarbonization. So how can policy improve or help decarbonization? For example, if we are able to incentivize people to move towards this cleaner alternatives. For example, if we reduce the taxes for electric vehicles, then the price of electric vehicles will come down, and people will be more incentivized to go or buy these electric vehicles, which have potential to reduce the emissions or the greenhouse emissions. Therefore, these different types of policies will also help achieve this decarbonization. So that's what we looked at in the first lecture. So in the second lecture, so we were focusing on alternate fuels, alternate fuel sources. As I said, like transportation sector is primarily dependent upon fossil fuel, right? So what are fossil fuels? So these are basically coal, natural gas, crude oil. Okay, so these are what we mainly call as fossil fuels, right? So these are non-renewable sources of energy, right? And this leads to a lot of greenhouse gas emissions as well. On the other hand, we have several non-fossil fuel based alternatives, right? So we can have like methanol obtained from biomass, right? So we have electricity produced from renewable sources. So all these will come under the non-fossil fuels, right? So we were looking at these alternate fuel types, and also what are some examples from around the world where these moves towards the alternative fuels have been taken place, and we looked at several success cases as well, right? So that's what we were focusing on the second lecture. And the third lecture was particularly focused on the electric vehicles, right? Electric vehicle as a sustainable mode. Right. So why electric vehicles is very much important for this move towards sustainability, because electricity has zero emissions, right? So when we use when the vehicles are powered through electricity, we'll have zero tailpipe emissions, right? Right. So how this electricity is produced, so that's a different story. But here we are only looking at the usage of electricity as the power source for the vehicles, right? So if we produce electricity in a cleaner way, right, then as a whole there will be zero emissions from EV mobility, right? So this will be a great step towards moving towards sustainable transport mobility, right? So therefore this lecture was fully focused on this. We were looking at what is the principle of an electric vehicle. So you compare with an typical IC engine vehicle. So in contrast to that, we will have generally a battery, right? So instead of the fuel source would be a battery that stores electricity. Then we have an electric motor which will draw electricity from this battery, and generate mechanical power to to move the vehicle forward, right? So that's a basic principle. And we also looked at different types of these electric vehicles, right? So we have several types. So starting from fuel cell based, right? So fuel cell basically it converts hydrogen and oxygen to produce electricity from it, right? So that's the fuel cell. And then we also have battery electric vehicles. So in this we have a battery which is charged, it stores the charge in it, and then that is converted by the electric motor into mechanical energy, right? So we also have hybrid electric vehicles. And hybrid electric vehicles, we have two sources of energy. So one is from the fossil fuel sources like petroleum, right? So we have petroleum, as well as we'll also have an a battery, right? So these two are present in a hybrid electric vehicle. So we have both sources of energy. And we also looked at what are the different benefits, merits, and some challenges associated with these, right? So we also looked at what are the different requirements that are needed for these electric vehicles. So in terms of their conversion efficiency and so on. Then in the fourth lecture, we were looking at an emerging, transport technology, right? So this, which was the Hyperloop, right? So if you remember from our very first lecture, we were looking at different forms of transportation. So there we looked at, when we are looking at rail-based technology, we were looking at this maglev trains, right? So this is one similar to the maglev train. So work on the same principle, but in addition to that, this is slightly different, more efficient as well, right? So in which we have basically a pod which will run through a tube that has very less atmospheric pressure inside, right? And then its propulsion is based on the magnetic levitation, right? So this is very efficient in terms of the speeds that it will achieve, in terms of low emissions that are from it. So this is a very a significantly it will give a significantly major improvement for our sustainable mobility. However, right now this is not really commercially available, right? Mostly in the development or the testing phases, right? So we are looking at the benefits and how much of environmental benefits that we would obtain from it, right? So there is a cost aspect as well. So it's much more costlier. But if you look at the the improvements in the capacity that we can carry, right, on the reduction in emissions. So this is much more friendlier to the environment. And finally, we in the final lecture we looked at one case study. So this was on the BRTS. So what is BRTS? BRTS stands for the Bus Rapid Transit System, right? So this is also one of the uh, more favorable steps towards achieving sustainability. How? By improving the attractiveness of public transit, right? So bus rapid transit system, as the name suggests, it is to enhance the efficiency of the bus transit mode, right? So by segregating the buses from the other street traffic, so we will be able to achieve higher reliability and efficiency. Therefore the people will be more attracted towards the use of buses, right? So therefore reducing our personal vehicle mode share, right? So we were looking at a case study, so which in which we looked at the trans millennium BRTS system. So this is in Bogota, Colombia, right? So this is one of the largest BRTS systems in terms of the network coverage. If you look at it, it has more than 125 kilometers of network length for the BRTS system. It's one of the largest in the world, right? So a very successful BRTS system. And we also have such systems in India as well. So we also looked at some of the BRTS systems like those in Delhi and Ahmedabad, right? So this was the content that were covered in this particular week. Now let's move on to some questions related to these concepts. So the first question for this week is, which one of the following is not an option for decarbonizing the transport sector? The first option is non-motorized transport, congestion pricing, promoting air transport, and user-friendly public transport. Okay, the poll is launched. So we have one vote for C. Any other answers? Okay. So the right option is option C, that is promoting air transport. Here we are talking about decarbonizing the transport sector, right? So as we already saw, what is decarbonization? So it is to reduce or eliminate the CO2 emissions, right? By our human activities, right? So that is what we call as decarbonizing, right? So here we the question is, which of the following options is not leading to this decarbonization, right? So if you look at the first option, non-motorized transport. So non-motorized transport is basically walking, cycling, and so on, right? So here we are not contributing to the CO2 emissions, right? So this is definitely a way of decarbonizing, right? So it's not leading to any emissions. Second, congestion pricing. So we have looked at in earlier weeks, right? So of different strategies to reduce the air pollution. So congestion pricing is one effective way, right? So where right, so during the peak hours, some corridors where there is heavy traffic towards the CBD areas. So there, the use of those corridors, will be priced at a higher rate, right? So there will be higher, like toll prices and so on, to be paid to use those certain corridors, right? So what does this do? It incentivizes people to use other routes, right, or to switch to a different time, right? So if it is not really necessary to use that particular corridor at that during the peak hours, so people can switch to a different route, or use that route on a different time. So this will help reduce the congestion, right? So when you are reducing the congestion, right, so the emissions will also go down, right? So higher congestion will also lead to higher emissions. So this will also help reduce the emissions generated from traffic, right? So this is also a way we can use to decarbonize. So D, user friendly public transport. So again, public transportation will also, when people use more public transport, yeah, right, so we can also reduce emissions, because the number of personal vehicles or private vehicles will go down, right? So again, significantly reducing the carbon emissions. Whereas promoting air transport will only increase the carbon emissions. Why? Because air transport is also a significant contributor to the greenhouse gas emissions, right? So if you look at the global CO2 emissions, so the aviation accounts for about 2.5% of the global CO2 emissions, right? So this is a significant percentage, right? So when you look at the global scale, right? So therefore, the promoting air transport is not a a good way when we are talking about decarbonizing the transport sector. So out of the four options, C is the one that is not really viable, right? So therefore, the right option is C. Okay, question number two is fuel versus food debate is about dash. The options are: food should be more expensive than fuel as it is a basic human need. Option B, food crops should be first utilized for feeding people rather than producing fuels from it. C is fuel usage should be minimized during the food production process. And D is agricultural land should be extensively used for fuel or oil storage. Okay, so we have one more for option C. Any other answers? Right. So the right option is option B, that food crop should be first utilized for feeding people rather than producing fuel from it. Right. So this food versus fuel debate. So the central point of this is whether food crops should be used for producing fuel or not. Right. So that's the central point of the debate. Right. So first let us look at some background. So if you look at it, certain food crops, such as corn, soya beans, and sugarcane. So certain food crops like these can be used, to generate biofuels, right? So this biofuel is basically alternative to fossil fuels, right? So as you can see, when I say it is an alternative to fossil fuel, already you can see how this is beneficial, right? So this helps, in achieving like decarbonization, right? So we are less dependent on fossil fuel if we are getting this biofuels, right? So these are more renewable, right? So than the fossil fuels, which are a non-renewable source, right? So on the other hand, what is the other viewpoint is, if these food crops are being used for fuel production, these are not going for feeding people, right? So which means there is so one side, decarbonization, so it's a positive from that aspect, whereas we have world hunger as a negative aspect, right? So because all this food is now being going for biofuels, which could have been used to to feed people, right? So there is a positive and a negative side, right? So in apart from this food not being available, the land that is being used for this food crops used for biofuels is also not available for producing other food crops which can be used for producing food, right? So that is the two conflicting viewpoints from it, right? So one set of people, positively argue that biofuels are better for the fuel for the fuel generation, whereas the other side argue that it is the we are wasting food which could be used for feeding people, right? So that is the food versus fuel debate, right? So what should we do with these, right? So in B is what is correctly explaining this food versus fuel debate. Like the debate is about whether we should use the food crop for feeding people or producing fuel. So that's the argument that we are having. So the others, they are not really related. What's given in the other options are not really related to this particular food versus fuel debate. Okay, question number 3 is, which one of the following is not a requirement of an efficient EV battery? So option A is high peak power output. Option B, low charge retention. Option C is rugged and resistant. Option D is varying operating temperature. Okay, so we go on with the option D. Any other answers? Right. Uh, so let's take a look at the answer. Answer is option B. It is the low charge retention. Okay. So here we are talking about EV batteries, especially which is not a requirement, right? Which means which is not desirable or not ideal, and we are talking about EV batteries, right? So the first one is high peak power output. So this is desirable because we need output. Power output means we can the vehicle can travel at a faster rate, right? So which is desirable. So option C says rugged and resistant. So which means that the battery is able to withstand extreme conditions, right? So like harsh temperatures, like impact due to road conditions or vibrations that it is subjected to due to road conditions. So if it is able to withstand all these harsh conditions, then we call it rugged and resistant. So this is also desirable, right? So you want our battery to be able to perform well, even when it is subjected to these conditions. So option D is very specific. Varying operating temperature means that the performance of the battery is not or the same. Performance is same under different climatic conditions. Right? So under different climatic or weather conditions, we will still get the performance, same performance. It performs consistently. That's what we mean by varying operating temperature. Again, this is also desirable, right? So if the battery is only able to perform in well when it is cooler and not when the temperature is hot. So that's not really ideal, right? So we want it to be performing or give the same performance even when the temperature changes a lot, right? So that's very desirable, right? So D is also a requirement. So whereas if you look at B, it says low charge retention. Low charge retention means the battery will be draining quicker, right? So charge drains faster, right? So charge drains faster, we need to keep recharging it more frequently, right? So that's not really ideal, right? So if you're going to travel to a long distance, right? So you will need the charge, to be retained in the battery for longer periods, right? So otherwise you have to keep making multiple stops, to recharge your battery, which will consume time, and also we need charging stations, right? So that's not really ideal, right? So we want high charge retention, right? So low charge retention is not really ideal, and therefore that is the one that is not a requirement of an efficient EV battery. We do not say that the battery has to have a low charge retention, right? So we should have high charge retention. So option B is the right answer. Question number 4 is cleaner electricity production does not help in decarbonizing the transport sector. So we have to say whether the statement is true or false. So we have one vote for A. Any other answers? Okay. So the given statement is false, right? So why it is false? So, because it says that cleaner electricity does not help, right? So it is important to pay attention to does not, because it says that it is actually does not help in decarbonizing. It actually increases the carbon dioxide emissions, right? So cleaner electricity production, which is incorrect. Why? Because see, when you talk about electricity, so when we use it, it's fine. It's always clean when we are using it to power something, right? So because there is no emission coming from the usage of electricity, right? But how is this electricity produced? So if you look at that, so basically we'll have two major sources. One is from fossil fuels, other is from renewable sources, right? So fossil fuel mainly from like thermal power plants, which are using, basically using coal, right? So here we have a lot of greenhouse gas emissions. On the other hand, if you look at the renewable sources, we can also generate electricity from solar power, wind power, hydropower, and so on. Right? So these is what we call it as the, the cleaner, so a cleaner electricity production. So when we say cleaner electricity production, it is from renewable sources. One, why are we calling it as clean? Because there is no emission, right, from it. So when there is no emission, so we know that it will help decarbonization, because decarbonization is to reduce the carbon dioxide emissions, right? So when we are using the cleaner sources, will have no emissions, and therefore electricity produced from it will be help in reducing the greenhouse gas emissions, right? So therefore it will help, right? So but the statement says it does not help, right? So therefore the statement is incorrect. So the right option is it is false. Okay, question number 5. Which of the following routes is proposed as the first hyperloop project in India? So the options are Delhi to Mumbai, Mumbai to Ahmedabad, Bangalore to Chennai, and Mumbai to Pune. So we have one more for D. Any other answers? Right. So the right option is option D. It is between Mumbai and Pune. Okay. So if you have heard of uh, Virgin Hyperloop One, so this is the company which has signed an agreement with the Maharashtra government, right? So to build the Hyperloop project in Maharashtra, so that is planned between Mumbai and Pune, right? So this is one of the first hyperloops, that will be in India. So and it is expected to be completed by 2030. Right? So that's when we can expect this hyperloop to function between Mumbai and Pune, and this is one of the first that is proposed. Right? So there are also others proposed, like there is one proposed in Andhra Pradesh as well. So between Amravati and Vijayawada, but this is also one of the proposed ones between Mumbai and Pune. So the one of the first proposed routes. So that hopefully we'll see by 2030 this first hyperloop project in India. So the right option is D, Mumbai, Pune. Okay, question number 6 is, which one of these is not a feature of an efficient BRT system? So the options are real-time passenger information systems, mixed lanes, integrated ticketing, and elevated platforms. For B, mixed lanes. Any other answers? Right. So the right option is option B. It is mixed lanes. So we know what the BRT is, right? So it stands for bus rapid transit, right? So BRT is bus rapid transit. So BRTS is bus rapid transit system, right? So here we have given a list. So we have to say which is not a feature, right? So which is not, seen or not, not designed in a bus rapid transit system. So first is real-time passenger information system. So this is very much a part of the BRTs. Why? Because BRTs, so this real-time passenger information system will, help inform passengers about, the next arrival of buses at a particular stop, how long it will take to travel between two stops and so on. So this is really helpful for passengers, to plan their journey. It will also improve the perception of the system, right? So they will know exactly how long they have to wait, right? So that will, make people more attracted towards this system, right? So we'll have and hopefully that will improve the ridership, right? So this is for a system, for an efficient BRT system, we need to have a really working real-time passenger information system. So that is required. So it is a part of the BRT system. Integrated ticketing is also needed. So integrated ticketing means, we have a single fare system that that can be used across different modes, right? So for example, we'll have metros, other rail transport, buses, right? So parkings and so on, for which we have to pay. So all this, if we have to have a different system, of payment, so that will be a hassle for the passengers, right? So but if everything can be brought into a single ticket, so people, it will be much easier for people, to get a ticket. So what they have to think about is pay a certain rupees to go from A to B, right? So if it involves multiple modes, that doesn't affect the passenger, right? So because they can travel with a single ticket, right? So that works on all these different modes, right? So for this, all the agencies have to come together, right? So that's really important. So but this integrated ticketing is needed, right? So it's needed so that the it is seamless to travel, between or using this system. So that is also a feature that is required. So de-elevated platforms, this is also a feature of the BRT system, right? So it is necessary because it improves the accessibility of the system, right? So it will be easier for people to board and deboard the buses, right? So this is also very much required. So mixer lanes is not a feature, right? So we know that BRTs have a segregated bus lane, right? So it has a separate lane for buses, dedicated lanes. So this is what is actually, making this a rapid transit system, right? So because there is less interaction between different modes, so buses can, travel at higher speeds, right? So the reliability of these bus transport, will be increased, right? So we can people can reach their destination faster. So if we have mixed lanes, then it will only be a deterrent, right? So this mixer lane is not a feature of an efficient BRT system. So therefore, the right option is option B. Okay, question number 7 is electric vehicles have dash emissions. The options are zero, zero tailpipe, zero evaporative, and all of the above. Okay. So we have one vote for B. So, and the right option is also B, that it is zero tailpipe. So when we are talking about emissions, so if you recall from 2 weeks ago when we were, introduced to modeling this transport emission, so we looked at, vehicular emissions had three types, right? So we had three types. So one was exhaust emissions, we had then evaporative emissions, and then the third was non-exhaust emissions, right? So these exhaust emissions are nothing but the tailpipe emissions, right? So what's coming from the tailpipe of the vehicle? So that's the exhaust emissions. Then we also have evaporative emissions, so which is, from the engines, and the third is the non-exhaust emissions, so which is coming from, tires and braking, right? So these are the three types of emissions that we have when we talk about vehicular emissions, right? And when we say electric vehicles have, lesser emissions or zero emissions, so what we really mean is this exhaust part, right? So because we are using electricity, there is no tailpipe emission associated with it, right? So we are not burning fuel, so the tailpipe emission will be completely zero, right? So electric vehicles have zero tailpipe emission. But when we have to say zero emission, so in that case, it means the zero, it has to be zero vehicular emission, right? So in that case, all the three components must not be present, right? But that is not the case. So with EV vehicles, we will still have evaporative and non-exhaust emissions, right? So therefore, it is not, completely emission free, right? But the major problem is the exhaust emissions, but and that is eliminated, right? So the correct option would be to say it has zero tailpipe emission, right? So but generally we'll say zero emission, but in that case it is understood that we are talking about the exhaust emissions, right? So but to be very precise, we have to say that it has zero tailpipe emission. So therefore the right option is B. Okay, question number 8 is the dash is the technology that has the potential to revolutionize sustainable transportation by providing a high speed, energy efficient, and low emission mode of travel. So the options are electric vehicles, hydrogen fuel cell vehicles, hyperloop, and all of the above. So we have one more for C, Hyperloop. Any other answers? Okay, so the right option is option C. It is Hyperloop. Okay, so here we are talking about a sustainable transport mode, and we are looking at three different factors: high speed, energy efficiency, and low emission, right? So, and we have three different options: SUV, electric vehicle, hydrogen fuel cell, and Hyperloop. So, in terms of energy efficiency and low emissions, so then all these three, perform, well, right? So they are low emissions, right? So low or almost zero emissions, right, in terms of GHGs, and they are also energy efficient, right? But what really differentiates here is the high speed, right? So this particular aspect, right? So compared to all the three, Hyperloop has a great advantage here, right? It really destroys the other two in terms of speed, right? Because Hyperloops can achieve in excess of, potentially it can achieve speeds in excess of 1,000 kmph, right? So this is, other two are nowhere comparable in terms of achieving these speeds, right? So therefore, looking at all these three aspects, so Hyperloop is that technology that can provide all these three, right? So energy efficiency, emissions, as well as the high speed, right? So therefore, Hyperloop is the right option. Okay, question number 9 is, which of the following cities uses 100% biogas for urban transportation? So the options are Stockholm, Linköping, Tokyo, and Bogota. We have one option, one vote for B. Any other answers? Right. So the right option is option B. It is Linköping. So this is a city in Sweden, right? So in the city, so they have been using 100% biogas, right? That is, all their urban transportation modes use only biogas for, as a fuel source, right? So their buses, cars, trains, right? So everything use biogas, right? So they have been able to achieve 100% biogas utilization for their transportation needs, right? Right. So therefore, they are not dependent on fossil fuels. So they convert their organic, wastes to produce biogas, and they have been able to achieve this. And this is there since the 1990s, right? So they have been doing it for a long time now, and this has resulted in about 25 percentage of CO2 reductions, right? So over these years, they have been able to achieve such high reductions in CO2 by completely switching to biogas for their transportation needs. So that is so because we know that transportation is a significant has a significant contribution. So this is the savings that we can expect, right? So by switching to alternate fuels, right? So this is one of the a very notable a case study from Linköping, Sweden, right? So it's just a very great example in relation to the sustainable transportation modes. Okay, question number 10 is the ASI framework does not comprise which of the following strategies? The options are avoid, shift, implement, avoid, shift, improve, assess, shift, implement, and assess, share, improve. So here, one vote for C. Any other answers? Okay, so the right option is option B. It is avoid, shift, and improve. Okay, so this ASA framework, so it is one of the policy frameworks. So with respect to decarbonizing the transport sector, so we looked at a different policy framework. This ASI is one such framework. So the ASI is basically coming from avoid, shift, and improve, right? So that's the AS and I in the ASI framework. So what does this mean? So avoid is basically to avoid motorized transport forms, right? So motorized transport, anything like cars, buses, so on. So anything that is motorized, we first have to try to avoid. So that should be our highest priority to reduce or completely avoid the motorized transport modes, right? So unless it is really necessary, we should try to avoid motorized transport mode. So second is shift. So when transport is necessary, so we try to shift from motorized to non-motorized to shift to environmentally friendly modes. Friendly modes. So this is basically encouraging NMTs. So where possible, so we can walk or use cycles, right? So that is the second step. So first we try to avoid non-motorized transport. Second, we try to shift to environmentally friendly alternatives. The third is improve. So this is to improve the vehicular efficiencies, right? So improve efficiency, right? So in terms of our energy efficiency, right? So we even if we are using motorized modes, so we can try to improve their energy efficiency so that our energy requirements come down, our emissions come down, right? So this can be done by promoting modes like electric vehicles, right? So that right. So this is the third step, right? So that we are cutting down on our carbon emissions. So, that's the in terms of priority. So first is avoid, second shift, third is to improve, right? So that's the ASAP. So the right option is B. So question number 11 is which of the following is the most energy efficient vehicle in terms of conversion efficiency of electricity? So one is internal combustion engine vehicles, second is fuel cell vehicles, third is battery electric vehicles, and D is all the options are equally efficient. For B, fuel cell vehicles. Any other answers? Okay. So the right option is actually option C. It is the battery electric vehicles. Okay. So here we are not talking about efficiency in terms of emissions. Here we are talking about efficiency of conversion efficiency. How much, how well this electricity is converted into the mechanical energy, right? So that's the conversion we're talking about, right? So we have electricity stored in the vehicle, and that is converted into mechanical energy to power the vehicle, right? So which of these engines is more efficient in doing that, right? So which means where there is lesser loss, right? So first, when we are talking about internal combustion engine vehicles, so here we are not using electricity, right? So here basically we are using fossil fuels like petroleum, right? So that is what is being used in the internal combustion engine, right? So as the word, so the combustion is basically combustion of the fossil fuels. Right? So therefore, this is not related to converting the electricity. But however, if you look at the conversion efficiency in general, so IC engines have a lot of moving parts, right? So we have clutches, we have differentials, right? So clutch helps you, disengage the gear from the engine. So the differential will help to split the power. So when we look at the axle, so there are two wheels, right, on either side of the axle. So sometimes, we have to the power needed on the outer wheel and the inner wheel will be different. This differential helps us to split the power to the two sides of the axle, right? So we have all these different moving parts that make up the internal combustion engine vehicles. So in that case, with more moving parts, there will be more losses, right? So with more moving parts, there will be more loss, and therefore the conversion efficiency will reduce, right? So if you look at it, so here basically we are converting chemical energy, right, from our fuel into mechanical energy. So if you look at a typical conversion efficiency, it will be around somewhere like 25%, right? So most of it is lost because of these different moving parts. So second, when we come to fuel cell vehicles, so here we are converting electricity into mechanical energy, right? But if you look at again, there are different moving parts in the different parts compared to a battery electric vehicle, right? So fuel cell as well as battery electric vehicle both are using electricity and converting it into mechanical energy. But in fuel cell, as we have seen, it is one type of the EV where from hydrogen we are generating electricity, which is converted to mechanical energy, right? So in comparison, if we look at the battery electric vehicle, we go from electricity to mechanical energy, right? So electricity actually is stored in the battery electric vehicle, whereas in fuel cell it is generated from hydrogen and then converted to mechanical energy. So again, if you see, so we will have the fuel cell, we will have compressor, for the gas and so on. So again, there are more parts that are involved in the fuel cell. Again, these multiple conversions will lead to more losses, right? So typically, we can expect around 50% or 60% conversion efficiency in a fuel cell, right? So whereas in a battery electric vehicle, this has the highest energy conversion efficiency. So typically around 90%, right? So because there's not much parts involved or not much moving parts that are involved in the BEVs, right? So energy is stored in the batteries, which is directly drawn by the electric motor to convert it into mechanical energy. So here we have the least loss in terms of the conversion, right? So if you look at the efficiency, so battery electric vehicles are the most efficient in terms of converting electricity. Okay, so therefore C is the right option. So question number 12 is, which fuel can be produced from water through hydrolysis using electricity? So the options are biodiesel, ethanol, methanol, and hydrogen. There is one more for D. Any other answers? Alright. So the right option is option D. It is hydrogen. Okay, so here, so the question is, we are starting with water Okay, and our final. Uh, so the question is, which of these is the final product that we can achieve, right? So that is the fuel through hydrolysis, right? And we are also using electricity for this, right? So hydrolysis. So in we are using electricity. So we call it electrolysis, which is basically use of electricity to break water, right? So water, as we know, it is made up of two hydrogen atoms and one oxygen atom, right? So that's the compound. So we use electricity and break it into hydrogen and oxygen, right? So we are so this is what we call as the electrolysis, and this hydrogen that is produced is a fuel source, right? So in our fuel cells, hydrogen can be used as a fuel. So we start with water, we end up with hydrogen through this using electricity through this process of electrolysis, right? So that's the final product. So in others, if you see, they are some hydrocarbons, right? So biodiesel, ethanol, and methanol. So they are not, so with just water, you cannot produce those things, right? So those are hydrocarbons. So with only water, through electricity, you can split it into hydrogen and oxygen. So hydrogen can be used as the fuel, right? So therefore, the right option is D. Okay, question number 13 is losses in electric vehicles occur due to cooling device that controls the battery temperature and energy consumption by the battery management system. So we have to say whether this is a correct or an incorrect statement. We have one vote for B, it is false. Neither answers. Alright. So the right option is option A, that the given statement is true, right? So what does it say? It says that losses occur. So when we are talking about electric vehicles, so the loss is the loss in electricity that is stored in the battery, right? So it occurs due to cooling device that controls the battery temperature and energy consumption by the battery management system, right? So it is giving us two sources, right, through which this loss can occur, right? And this is correct because so temperature actually plays an important role when we are talking about the capacity of batteries, right? So you might have noticed this with your smartphones, mobile phones, right? So when its temperature increases, right? So when you are using it a lot or putting it through a high workload, right? So the temperature, the phone will get heated up, right? So in those cases, you might notice that the battery drains faster, your charge will go down quickly, right? So temperature is really important, right? So that's why we need the cooling device. So that's an important source. So when that is not properly doing its job, so we can observe losses, right? So second is energy consumption by the battery management system, right? So what's this battery management system? So for example, if you're using the vehicle, so you need to let you know what is the current level of charge that is there in the system. If there is any issue with the battery, right? So for the diagnosis and so on, so we have the battery management system. So to run that, so we need some energy, right? So everything requires some energy to run. So the electricity for that is also drawn from the battery, right? So when that is consuming the energy, so not much. So if that is going to consume more energy, so the energy that is available for propelling the vehicle reduces, right? So the energy consumption of the BMS or the battery management system is also a loss, right? Loss not in terms of loss in the conversion process, but not loss in terms of not being useful for the purpose that we are intending to do, which is to propel the vehicle, right? So therefore, that is also termed as loss here, right? So therefore, these two sources are correct. Therefore, the given statement is true. Okay, question number 14 is the well to tank emissions for electric vehicles mainly depend on dash. The options are battery efficiency, electricity source, vehicle maintenance, and vehicle traction system. We have one more for B. The other answers. Right. So the right option is option B. It is the electricity source. Okay. So here we are talking about well to tank emissions, right? So if you recall from our previous lectures where we looked at LCA and so on, there we were talking about system boundaries, right? So right from where to which part of the system, right? So where does our system start? Where does our system end, right? So all our analysis are confined to the system, whatever happens within the system. So here basically we can divide this system into two major parts. So one is so this will comes from refers to the source, right? So from where we are generating electricity. So typically as we mostly use fossil fuels, so this well is coming from like the oil wells, right? So but it could be other sources as well. So the well is our the source. Right? So then we have electricity production, and then we have tank is basically to the tank of the vehicle, right? So again, when we are talking about electricity, it is to store in the vehicle's battery. So that's what we are referring to as tank here, right? So the charging station to the charging station, right? So this is the well to tank part. So we can extend this further, right? So we have the vehicle, right? So the vehicle movement. So that is referred to as well to wheel, right? So we have well to tank. If we look, if our system is confined only up to the charging station, right? And if we look at the emissions from the vehicle movement as well, so then in that case our system will be called as the well to wheel. Okay, so here we are talking about well to tank, which means we are only looking up to this particular part, right? So here we want to know what are what the emissions depend upon, right? So in all this, if you look at the different options here, so the battery efficiency, vehicle maintenance, vehicle traction. So all these three are related to the vehicular part, right? So these three does not come into the well to tank portion of our system, right? So all these three belong to no vehicle, right? So if we are only concerned about well to wheel, then we will be including these three factors, right? So because these will affect the vehicular emissions, right? So we looked at the exhaust, non-exhaust, and the evaporative, right? So all so these factors will affect the vehicular emissions, right? So but this is not part of the analysis that we are doing here, right? So these three can directly be eliminated because they do not influence. So the electricity source is related because how we are generating the electricity, right? So this electricity production will has emissions. So during the electricity production, so we will have emissions, and the amount or whether or not we will be having emissions is directly related to the source, right? So if we are using cleaner source, renewable source, then we will have zero emissions, right? So but if you are using fossil fuel based sources, then there will be a lot of emissions, right? So the electricity source plays a important role when we are talking about the well to tank emission, right? So therefore B is the right option. Okay, question number 15 is, which of the following is a component of Hyperloop? So the options are capsule, tube, propulsion, and all of these. Then we have one more for A, capsule. Any other answers? All right. So the right option is option D, all of these. So when we are talking about Hyperloop, so there are multiple components that make up the Hyperloop technology. Right. So the capsule is nothing but the pod or the moving component of the Hyperloop, right? So in which which carries the people, right? So that moves. So that's the capsule part, right? So the pod. So this is part of the system. The tube is the tube, within which the capsule moves, right? So we have this tube which provides this low pressure environment through which the capsule moves. So the tube is also a part of the hyperloop. So this is one of the components. And third, how does it move? It needs a propulsion system, right? So the magnetic levitation, based on the magnetic levitation principle. So the hyperloop is propelled or moved. So this propulsion system is also one of the components, right? So one of the important components. So all these three are there in a hyperloop. So when you take a hyperloop system, so all these three will be there, right? So therefore, option D, all of these is the right answer. So without any one of them, so it's basically useless, right? So when you have just the capsule or the tube or the propulsion, it's not really a hyperloop system. Okay, question number 16 is hyperloop is based on the principle of dash. It's fuel-based propulsion, electromagnetic levitation, photochemical reaction, and fuel combustion. We have one more for B, electromagnetic levitation. Any other answers? Right. So the right option is option B, electromagnetic levitation. So by this time I have mentioned this multiple times. So uh, the, the propulsion system for the hyperloop is based on electromagnetic levitation, right? So there is no fuel that's used to power the vehicle. It's based on the electromagnets that are used to lift the vehicle and move it forward, right? So that provides us the least amount of friction and also what's giving us the low emission advantage of this hyperloop technology. So it is option B. Okay, question number 17. Trans-Milenio Bogota is an example of dash, metro transit system, light rail transit system, bus rapid transit system, and rapid rail transit system. So we have one vote for C. Any other answers? Okay, so the right option is option C. It is a bus rapid transit system, right? So we saw this Trans-Millennium as part of our case study, right, in the fifth lecture of this week, right? So this we called it as the BRTS, right? So the bus rapid transit system. So this is one of the notable examples from around the world because this is one of the largest systems with respect to BRTS in terms of the network coverage, right? So we saw that it has excess of 125 kilometers of network length for the BRTS system. And not only that, it's one of the most successful systems, right? So like around 2.5 million passengers are traveling using this BRTS system in a day, right? So it's one of the most successful, right? So and it has a lot of advantages, right? So in terms of reducing pollution and so on. And if you look at it, so also it runs at a higher frequency, like 2 3 minute frequency, right? So it's a very a very successful and one of the largest systems in the world for BRTS. One of the notable examples. So the right option is it is C. It's a BRTS system. Okay, question number 18 is which of the following is not a requirement of an ideal electric vehicle battery? Options are high energy capacity, good charge retention, made of expensive materials, and high peak power output. There is one vote for C. Okay, any other answers? Right. So I think this is an obvious one. So the right option is C, made of expensive material. So we already discussed about the requirements of an ideal electric vehicle battery, right? So in terms of efficiency, we looked at. So what's really desirable. So in that case, so we discussed, how high energy capacity, charge retention, and the peak power output are, really required, right? So made of expensive material. Obviously, we don't want the battery to be made of expensive material. Why? Because if it is made of expensive material, then the cost of the battery is going to be higher, right? So that will increase the battery cost. So if battery cost goes high, what will happen? The EV cost, the electric vehicle cost will also go high, right? So then in that case, there will be lesser people buying and using the EVs, right? So which is not what we want, right? So therefore, it is not. So C is the right option, that it should not be made of expensive material. Okay, question number 19 is which of the following is a non-fossil fuel alternative for transportation? So the options are methanol from natural gas, methanol from biomass, compressed natural gas, and butanol. Let's vote for A. Okay, we have one vote for A. Any other answers? Alright, so the right option is option B, that it is methanol from biomass. Okay, so here we are talking about alternative fuel sources, specifically non-fossil fuel alternatives, right? So which means the alternative source should not be produced from a fossil fuel source, right? So we have the fossil fuels like petrol, diesel, natural gas also is a fossil fuel, right? So we need a fuel that is not from these, right? So that's the alternative, but that alternative should also be from non-fossil fuel, right? So as I said, natural gas is also a fossil fuel, right? It's not renewable, right? So, and methanol produced from natural gas is not a non-fossil fuel alternative because we need the fossil fuel to generate this methanol from natural gas, right? So therefore, this is not the right option. All right. So methanol from biomass. So this is correct. So biomass is not a fossil fuel, right? So it is renewable, right? So methanol we can also be generated from biomass, right? So as it can be generated from natural gas, but generating methanol from biomass is a non-fossil fuel alternative. So we have CNG. CNGs are also fossil fuels, and butanol. So in the case of butanol, similar like methanol, butanol can also be produced from both fossil fuel as well as non-fossil fuel, right? So we looked at this food versus fuel debate, right, where food crops can be used for generating biofuel. So this is one of those biofuels, right? So butanol can be derived from the food crops, right? So but here the source is not mentioned, right? So from where we are deriving this, as I said, both fossil fuels and non-fossil fuels uh, can be used to obtain this butanol, so we do not know, so therefore this is ambiguous. So the right option is option B, that methanol from biomass, right? So that's the non-fossil fuel alternative here. So question 20 is, which of the following is not an example of an avoid measure in the ASI framework? So the options are investing in public transportation, promoting telecommuting and work from home arrangements, encouraging walking and cycling, building more roads and highways. We have one vote for D. Any other answers? right? So here we are talking about the ASI framework, which we looked at before, right? So what was the ASI? So A stands for avoid, the S stands for shift, and I stands for improve, right? So when we say avoid, what are we avoiding? So we are avoiding motorized transport, motorized modes. Right? So that's what we are trying to do when we avoid step of the ASI framework. Right? So here the question is which is not an example of avoid, right? So which is or which will encourage or increase the motorized mode use. So that's what we want to identify from the given options. So the first option says investing in public transportation, right? So this helps avoid or reduce the use of private vehicles, right? So when we are saying avoid motorized modes, so public vehicles, so public transit will also come under motorized mode, but relatively it will decrease the use of personal vehicles, right? So while there will be still motorized modes, but it will reduce the amount of vehicles that are on the road, right? So therefore, this is investing in public transport is helps to achieve this avoid, right? So to a certain extent. So therefore, A is an example. So B, promoting telecommuting and work from home arrangements. So this also helps avoid motorized mode. Why? Because it reduces the need to travel, right? So telecommuting and work from home reduces the need for people to travel. Therefore, when the need to travel reduces, the use of motorized mode will also come down, right? So therefore, B is also an example of the avoid measure. C is encouraging walking and cycling. So walking and cycling are non-motorized modes, right? As more and more people use walking and cycling, the use of motorized mode is coming down. So this is also an example of avoiding. So D is building more roads and highways. So obviously, so this is the incorrect or the correct option for not an example, because more roads and highways will encourage more, for personal vehicle use, right? So therefore, more vehicles will be added to the system. Therefore, D is not an example if you are looking at the avoid measure in the ASF. So therefore, the right option is D. Okay, question number 21 is which of the following is not a challenge to decarbonizing the transport sector? So the options are the high cost of zero emission vehicles and fuels, the lack of a supportive infrastructure for zero emission vehicles, the need to change consumer behavior and attitudes towards transportation, and D is the increasing availability of renewable energy sources. One more for D. Any other answers? Right. So the right option is option D, the increasing availability of renewable energy sources. Okay, so here question is which is not a challenge. So not a challenge means like which is helpful. So which is not deterring our move towards decarbonizing the transport sector, right? So if you look at each of the options, the first one says the high cost of zero emission vehicles and fuels, right? So the high cost is a deterrent, right? So which it de-incentivizes people to purchase these vehicles, right? So therefore this is a challenge, right? So this is a challenge. So option B is the lack of a supportive infrastructure for zero emission vehicles. So the lack of the infrastructure is also a challenge, right? So for the electric vehicles, we need to provide the charging infrastructure, right? So if we do not have enough charging infrastructure and also a good network of this charging infrastructure, then people will be less incentivized to use it, right? So because where people want to go, they may not be able to go because the charge will not be enough to reach there, and they will need charging stations. And if it is not there, they will not prefer to use that, right? So we need to address that. That's a challenge. See, the need to change consumer behavior and attitudes towards transportation, right? So changing people's behavior, people's attitude is a challenge, right? So the changing the mindset of the people, right? So people, generally, owning a private vehicle, owning a car is, generally seen as a, social status, right? So when you own a car, people, see that as a, high social status, right? As having high respect in the society, right? So which means people will buy more and more cars and two wheelers and use that rather than preferring to use public transport, right? So this is a behavioral attitudinal change that is needed in the society so that we are able to achieve this decarbonization, right? So that is one of the challenges that we face. And D is the increasing availability of renewable energy source. So this is not a challenge, this is helpful, right? Why? Because renewable sources do not contribute to the emissions, right? So therefore they are not going to generate carbon dioxide, so that helps us move towards decarbonizing, right? So the increasing availability is a good thing, right? So which means we'll be able to use these renewable sources, from hopefully at a cheaper rate in terms of cost than the fossil fuel, so that we'll be achieving the decarbonization, right? So therefore D is the right option, which is not a challenge. It's helpful in moving towards the sustainable transport modes. The question 22 is, which of the following is a challenge to implementing the Hyperloop technology for sustainable transportation? Options are potential to increase congestion in urban areas, high energy efficiency, public acceptance, and none of the above. You want to look for D, none of the above. Okay, any other answers? Alright, so the right option is option C. It is the public acceptance. Okay, so here we want to know which is the challenge, so which it is against this hyperloop technology, right? So first one says it is the potential to increase congestion in urban areas, right? So this is incorrect, right? Why? Because hyperloop will help reduce congestion, right? It will help reduce congestion. So same similar to how if we improve public transit, it's going to reduce congestion. So this is again another form of the transit technology, right? So it's one of the mass transport facilities. So it will help reduce congestion from the roads, right? So therefore, uh, so the statement itself is incorrect. So it's not, and also it is not a challenge. So B is high energy efficiency. We know it is energy efficient, right? So its high energy efficiency is one of the attractive features of this technology, right? It's not going to deter our the implementation of it, right? It's an advantage which actually uh, you know uh, wants us to makes us to go for this technology, right? So this is not a challenge. Public acceptance, right? So this hyperloop is it's a very new technology, right? So it is not thoroughly tested, right? So it's and therefore we do not know how people perceive this, right? So how much people will accept it or will be ready to use it. So that's really no one really knows for sure, right? So getting people to trust the technology, right, and embrace it. So that will be a challenge actually, right? So therefore, public acceptance is a challenge because this is a new technology and it's not really implemented, so we do not know the people's mindset, right? So public acceptance it may be one of the challenges when we are looking at the hyperloop technology for transportation, right? So therefore C is the right answer. Okay, 23 is which of the following is not a way to ensure that an EV is a zero emission vehicle? So the options are charge the EV using a renewable energy source such as solar or wind power, use an EV with an onboard hydrogen fuel cell, charge the EV using electricity from a coal-fired power plant, and D is all the above are ways to ensure that an EV is a zero emission vehicle. Okay, so we have one more for C. Question 30. Okay, let's finish this one and then go back to that. Right, so the answer for this question is option C, to charge the EV using electricity from a coal-fired power plant, right? So here we're talking which is not a way for a zero emission vehicle, right? So here understanding the term zero emission is important, right? So this is where the previous question where we looked at the emissions from electricity vehicle, electric vehicle, helps, right? So there we discussed about zero emission, zero tailpipe emission, and zero evaporative emission, right? So we had these three types of vehicular emissions, and we can say it is zero emission if all the three emissions are zero, right? So only in that case we'll have zero emission. So here, when you are talking about charging the EV using electricity from a coal-fired power plant, so in that case, it's not truly a zero emission because when we are looking at the well to wheel, right? So in the wheel part, right? So there is no emission, right? So the vehicle is not generating any emissions, but from the source of the electricity to produce the electricity, we are using coal-based coal-fired power plant. So where the emissions are produced, right? So in that case, truly using this EV is not zero emission, right? So to run this EV, we are using the electricity which is produced using fossil fuels from where emissions are generated. So in that case, if you look at the whole well-to-wheel system, it is not truly zero emission, right? So, but in the other cases, when you're using hydrogen fuel cells, electricity is generated from the fuel cell where hydrogen is used. So, in that case, the water will be the output, right? So, there you do not have emissions from the electricity production. Using renewable source, again, from such as solar, wind power, there is no emission, and we are generating electricity from such sources. So, therefore, C is the option where it is not a zero emission. Okay, therefore, C is the right answer. Question 24. Okay, let's look at question 13 that was asked. Yeah, question 13 is we looked at it, right? So the losses occur due to cooling device and due to the battery management, right? So we said that the given statement was true, right? So here it says loss occurs due to cooling device and the battery management. So we saw how it can occur, right? So the cooling is one of the is really important when we are talking about the batteries, electricity, the charge retention, right? So high temperatures can lead to faster battery drainage, right? So the charge will drain faster. So the cooling device is important to ensure that the temperature of the battery does not exceed certain limits, so that the performance of the battery is maintained, right? So if it's not going to function properly, it can lead to losses, right? So here we're not saying having the cooling device will cause issues, but this is one area or one source which can lead to the loss, right? So it occurs due to the cooling device. If it is not going to function properly, it can lead to loss, right? So that is true. It can occur due to the cooling device. So the other part is in the BMS, battery management system. So in that case, so to run this BMS, so we will need the electricity, which is going to be again consumed from the battery itself, right? So that's going to lead to loss in the electricity that is stored in the battery, which is not going to be used for propelling the vehicle, right? So the battery is being drained by the BMS, for its functioning, right? So that from our perspective, that is a loss, right? So it's not available for the primary purpose, which is to run the vehicle, right? So therefore, these are two sources from which losses can occur. So the statement also says loss will occur in the electric vehicle because of these two, and that is correct. Okay, is it clear now? Okay, so let's go back. So question 24 is the limitation of hyperloop does not include dash. The options are critical situation at turnings, sensitive to weather, less passenger, movable space and comfort, and possibility of dizziness for passengers due to high acceleration and deceleration. We have one word for me. Any other answers? right? So the right answer is option B. It is sensitive to weather. Okay, so the question is which is not a limitation, right? So of Hyperloop technology, right? So option A, critical situations at turnings. So this is one of the limitations, right? So it is because it travels in a tube at high speeds, right? So turning maneuvers are going to be very critical, right? So it has to be done at lower speeds, right? So we cannot make sharp or sudden turns. So that has to be handled properly. Right? So that's it's one of the limitations. So right, so we have to properly plan the the lines or the routes that it will take. Then C, less passenger movable space and comfort is also a limitation, right? So because if you look at the typical design of these, the capsule or the pods, we'll see that the capacity will be in the range of 25 to 30 passengers, right? So that's how it will be very compact. So the space available for people to move is going to be much lower than what you will see in other rail systems like metro or so on, right? So that is one of the limitations. And the possibility of dizziness, right? So due to the high acceleration, deceleration is also a limitation, right? So we looked at how the speeds at which it can travel, right? So it has to go, it can travel at speeds larger, higher than 1000 kmph as well, right? It has to go from 0 to 1000, so it has a high acceleration deceleration capacity as well, right? So but not everyone will be able to be comfortable with that, right? So it will cause dizziness, right? So that's also one of the limitation that needs to be addressed. But sensitivity to weather is not a limitation. Why? Because this is an isolated, isolated from the the outside environment, right? So we saw it travel. The tube is one of the component of the Hyperloop system. This capsule moves within the tube, so the rain or the outside heat is not going to affect inside the capsule that is inside. So it can run in all weather conditions, right? So therefore it is not sensitive to weather. The operation of the hyperloop is not going to be dependent on the weather outside, weather conditions outside. So that is not really a limitation of this technology, right? So therefore the right option is option B. Okay, so any questions from this week? We have come to the end of today's session. Yeah, so you can ask your doubts now. So if you do not have any questions, you can log out and we'll meet again next week. So otherwise, you can ask your questions. Okay, so yeah, please type in your question. Okay, so question on the hyperloop. Let us see. I'll just go through the question. You just let me know which one. There are multiple questions on hyperloop. Was it this one? So the question is on about question 16 or 17? 17. This transmillennium. Okay. So the question is, what is the system? This transmillennium, what kind of a system this is, right? So if you look at the fifth lecture of week 10, so this was discussed, right? So it was a case study on the BRTS system in Bogota, right? So that's called Transmillennium. It's the name of the BRTS system that is implemented in Bogota. So it's a place in Colombia, right? So there we have this BRTS system. So, so this Transmilenio is one of that system. So this is just asking what kind of system that's implemented there. So it's a bus rapid transit system. So that's the right answer. So I was discussing about the different features of this system. So in terms of the network coverage, ridership, and the frequency of the system. So do you have any specific question on this? Like what did you not understand? Okay, explain hybrid. So are you talking about the hybrid electric vehicle? Park before the session during the overview? Is it? Are you talking about this? The HEV? Okay. So we have different types of uh, electric vehicle. When we say electric vehicle, so in general, what we mean is the vehicles which use electricity, as the source of power, right? But there are different types of it. So based on how this electricity is generated and so on. So this hybrid electric vehicle, so it will have two fuel sources. One will be your regular IC engine will be there. So the internal combustion engine, which works on petrol, right? So generally petrol, diesel, right? So that is one of the sources, and will also have a battery, right? So which will store the electricity, right? So we have both of these in the vehicle. So the hybrid comes because hybrid means there are multiple sources of energy, right? So different forms. So both are being present in the vehicle. That's why it's called the hybrid source, right? So we have the petrol source as well as the battery source. Do all hybrid work the same way? So may not work the same way. So this is one particular configuration. So where we have the IC engine as well as the the battery. So we could have other as well. For example, CNGs combined with electric batteries and so on. So hybrid is basically it's a one category of this electric vehicle. Yeah, yeah. If it is petrol, then it has its own engine, right? So yes, so those are two completely different things. So the petrol engine is not is different from the electric motor that uses the battery power, right? So those are two separate things, but present on the same vehicle, right? So the same so the petrol is not used to drive the electric motor, or the battery power is not used to run the IC engine, right? So both of these have their separate engines, but both present on the same vehicle, right? So you could use either this one or that one. Okay. So any other questions? Okay. Okay. So if there are no further questions, we can wrap up the session here. We'll continue next week. Okay. Same time. Thank you for attending.